For those of you who may not have come across Sapphire, and we were originally established 31 years ago in 1992, not very far from here. Sold 30,000 balconies in the last 5 years. We'd manufactured 6,500 balconies this year. We're 100% focused, so all our effort and energy and our knowledge is put into this particular area. We're part of the BS 8579 committee, which wrote the balcony standard a couple of years ago, and also hold the record for installing 62 balconies in a single day. We've not really talked about the products today, but to give you a really quick overview, the arms are the first part of the balcony that can be constructed with any kind of substrate, usually RC frame or the cast in the early stages of the building to be dumped. After facades finishing and bring the balcony, which is a pre-manufactured cassette balcony from one of our 9 factories in the UK. The simplicity of the install gives it +/- 20 mil of tolerance and also enables a rapid speed there. And also last but certainly not least, inside the building is where the people are, which installed it. And that's becoming more and more robotic. And that would be installed that it would get taped within the building rather than right underneath is. So the last thing you want to hear at near 4 o'clock in the afternoon is a big old content list of what we're going to look at. So it's all in a Churchill style speech. But I can't do a very good Churchill impression, so I'm just going to pick out a few pieces here. The first bit is that we're not merely going to look at the future. We're going to delve into what has happened, what is happening right now, and then look at untangling some of those complexities and look at how we should actually take out things into the future in a more holistic way. So during this presentation, the first thing we're going to look at is balcony materials and how that's been changing over the last 10, 15 years. We're going to look at a few topical incidents which have happened. We did a massive research piece with all the brigades across the country, visiting a lot of the incidents which happened, speaking to investigators across the compliance services. We're going to touch on laminate glass. Good to get a few questions already coming in today. We'll talk about some of those potential solutions and challenges around that too. And lastly, looking around the kind of current changes in legislation and emerging trends in the industry and how that is likely to be at the future of balconies. So I was stereotyped after the concrete balconies where we were basically applied as a benefit of the architectural metalwork, the balustrade guarding. So at that stage, balconies were very much being range different types of project, different shapes of solve, from kind of standard rectangular shape through to the bottom right-hand side for the tower being wrought, where you've got basically the shape of the human eye. And we'll have us look a bit more of those pictures have their close rappel section as well. So this stage here, this was the most common method in the UK going back really into the GFC predominance. In Canada, some of the other marketplaces we work in, concrete still is the lane chosen method of balcony, partly because other countries don't have the same requirements for thermal breaks as we do in this country. So the manufacture and the process of Kazaki and what those balconies were manufactured from started with a linear thermal break, waterproofing generally applied to the slab, site work 100% on the sites, so lots of teams, lots of people installing roughly about 1 to 2 balconies a day with railings, and then somebody else would come and install the timber decking, soffits would be painted or added up. There's an extensive scaffolding so you can load out the glass and so on and take that across to the balcony. It's an old stick. Steel balconies started becoming common in around 2009, and the reason for that was basically with the GFC, people's budgets were under pressure, and people kind of called together packages and responsibility go to one particular person and cut the price at the same time. At the start, that was very much rectangular, as you can see on the shapes here. That is still a very common method in the UK of how to manufacture balconies. Unlike a concrete balcony, you don't have a linear thermal break. You've got a smaller thermal break, so it's better from a carbon and thermal performance point of view. We got, in this particular case, you've got 5 anchors here. Installs done from the bottom, and that was the main balcony part. It's manufactured off-site. And then you basically bring them in, you're installing one, standing on that one to actually access the bolts and the underside of the mix for that. Because you need to access those bolts, 30% of that work is actually done on-site. And that means that soffit became expensive because you've got 2 people, typically one person holding, one person fixing, to actually install 4 soffits. As a result, soffits are emitted. This is quite an important fact when it comes to how incidents have happened and the damage which is caused. I'll come back to that in a second. And again, at this stage, timber wood deck was still very much the main choice, although from around 2010 time to 2012, people were starting to look at wood plastic composites. So also the kidneys like thermo woods and so on, was the basic softwood, much right by the DLI stuff. That really moves to get into the glide-on balcony, which is what I showed you at the beginning there. Our first project is one in the top left there, 22 balconies, all which are installed in the same day. And since that point, all the balconies we manufacture, both here in the UK and around the world, are all aluminium glide-on balconies with a combination of mild steel and semi-fin backing stability. So more likely steel balconies, you've got smaller thermal breaks because it's an aluminium structure. It's only 345 kg for a typical 6 square metre balcony, which is hanging outside the building. I mean, you can use less anchors. Most balconies now only have screw anchors. Obviously, best for their penetration point of view. We'll look at that a bit later and how that affects fire bullets. Installs dumped inside. Only the last deck boards and the final connections, therefore, have to be done on site, and it was only about 5% of the work per balcony was done on site now. Because you don't need to act as a bolt underneath, it means you can install soffits in a factory environment. It takes about 15 minutes for one person rather than 2 hours for 2 people, as it was at the site. And what that means is that if you emit soffits, you have to powder coat with fix and so on like that, and it becomes a cost-neutral solution. Because it's a cost-neutral solution, the majority of people choose control graded. And that's great from a fire point of view and for a drainage point of view as well. Let's talk about the transition towards wood plastic composites. At the first stage, when we launched Glide-on Balconies was 2014. At that stage, the most common choice in the market was wood plastic composites. The reason being, use a clip system, very easy to install, and the price was coming right down because there's more and more non-UK plants than auditing for the UK. That's obviously changed quite considerably since then, and now the main problem is actually an aluminium deck board. So we're going to look at balcony fires, but we're going to look at them in the light of pre-Grenfell and then look at post-Grenfell. So in 2016, the government had identified that there was an issue with balconies and the occurrence of balcony fires was increasing. They commissioned a report from BRE titled Fire Safety Issues of Balconies, and that was delivered in July 16. Now, the highlight to take to the bottom there, that the evidence would suggest that fires of balconies appear to be increasing, but not impacted on life safety. And for that reason, it wasn't recommended they needed to add that to Part B, basically. That's obviously quite relevant there. The other thing is that the balcony methods in that period of time, and when those fires have been happening, have been changing a lot. And yet the most recent one in this report was 2011. So there was quite a gap there of knowledge, 5 years, when the connectors might less changed quite a lot. This is one of the most interesting incidents which happened. Some of you may have seen this incident which happened in Brixton. It started with a barbecue fire at their fleet. You can see in the very combustible materials there, softwood, exposed, no soffits. It burned me on train. What actually happened here is a motorbike was parked on the balcony and it exploded. I don't know how the motorbike got there in the first place, but what I do know is that was a major effect which was caused by not just the material which was used there in the balcony, but also how the user was actually using their valve. So this is actually where our journey into balcony fires really increased. When we started bringing it back there, this is still pre-Grenfell, but this is actually one of our balconies. And the reason this is quite interesting, hesitating to sift that, is that the balcony above, somebody was smoking a cigarette over the edge of the balcony balustrade, which coincidentally is none they got. Landed on the balcony below on their beanbag. The beanbag caught a light, caught the Dexia light. When the fire brigade got there, you can see the splash of glass, and they've cut the deck board straight to stop it spreading along. That was a Class C deck board. But the fundamental thing we could use on this balcony, which made a big significant difference, is that use the Class A, the 2, and soft aluminium. And what you can see there is the fire has been contained to that one balcony. The one above is smoke damage, yes, but the other one where the actual fire occurred and was able to be replaced and taken off the building, but ultimately hadn't spread inside the building and up to other floors. So at the time of Grenfell, this is how a typical balcony was being constructed. Typically the anchors were generally an off-the-shelf system, typically using polystyrene-based thermal brakes. And in the main project-specific design, one project could be very difficult to the other, and every site created basically around that policy could vary heavily. At this stage, you said balconies typically had a glass balustrade. Laminated glass was definitely the norm, and that accounted for more than 80% of balcony balustrade in that stage. Most of the decking choices was a Class C composite, and the market was in that transition to actually use the soffits, which was a very good move from the sake of quality. So laminated glass. So when did we come popular? Well, one of the critical, very sad instance which happened was in Sheffield, where unfortunately a balustrade glass panel had spontaneously fractured. Don't know the cause or whether it was nickel sulfide or whether it was impact, but there was a gap in the balcony balustrade. Unfortunately and very tragically, a young child fell through that gap with her death. But that woke up an obvious window in the industry to the risk of easily monolithic glass. As laminated glass, back in the day, as I referred to earlier, using monolithic 92mm glass was a very, very common choice by Hill in stadiums and retail stores and so on. However, getting hold of those materials now is actually very difficult in comparison to what it used to be. And the reason being is that being of Plato, acknowledged the fact that you didn't need to fulfill the requirements of 6.8 with the STU, which says that you had a second floor guarded, and it has to take the structural load if you use a laminated glass. So that meant that we didn't have to have structural handrail. It was a nice meat trim pre-laminated glass. It did a second floor guarding. So that brought down the cost significantly as more and more people adopted it. So post Grenfell, put your hands up if you pull this picture in the time of New Year's Eve. They go to, so some of you see it. So a really horrendous fire started on the 9th floor. I visited site with the Manchester Fire Brigade and the person who investigated that. There was a chip out of fire, so the boiler chip had out to the outside of the balcony, and it rapidly spread from the 9th floor down to the 8th all the way out to the 14th floor. Sadly, they didn't learn the lesson. They actually repaired the building without improving it, and they had a second balcony fire. Not so significant, unfortunately, but that happened during their second lockdown. So the two findings there, or the two suggestions at that point, and then one is this pre-hack it, the board and so on, was that you would remove all timber from a balcony and then you use metal soffits and metal because it affected heat weight in the way it would be done better from a cementitious board or something like that. So we're obviously very familiar with these, the consultations and so on. During the period of consultation, there was also a spree of balcony fires, and a 6 and 2 week period. This is one of the most significant ones. I visited with the London Fire Brigade to that site. One of the officers had attended. He saw the damage firsthand. It started on the podium level from smoking. It then caught an eye on the deck in there. It caught the soffit and eye on the balcony above. And then it rapidly spread throughout the building, the stone into the environment, so it causes significant damage. So we then had the announcement of and for the clarity of the exemption list, or lack of clarity around the exemption list, and so on, 28th November 18. This obviously brought a significant effect on the balcony balustrade because windows were listed, the laminate was listed as an exemption, but wasn't listed as an exemption for balcony balustrade. So with that, we actually had an event worked with our sister brand, ResiBuild, and the MHCLG were there at the time. We had the opportunity to ask them about it. They said, oh, sorry, it's been inadvertently missed, but here we are, 2023. It's still inadvertently missed and wasn't quite useful for the industry, I think. Many of you have probably seen this incident here happen on a Sunday in 2019. Quite a horrendous fire. But what made this very significant in the balcony terms is not just the extent of the uplifts to the extent of how badly that burned, was the fact there was a podcast done with the BBC of a resident meeting with us at the back. Two questions there. One was about whether this complied with regulations, and the response said the start it's below the 18-metre mark, and the second one was, is it acceptable for buildings to burn like this, even if it complies to regulation? Now, what makes it even more interesting is that there was the fire state this was issued called under 2 topics just a few weeks afterwards. I forget the exact comment, it was within 15 days of each other. And the recommendation there was the fact that all the combustible material of the balcony should be replaced. The second one was pointed to the report, which we brought up at only one of the slides we looked at, about regardless of height, the external walls of the building should adequately resist the spread of bath. Obviously, we've seen those of the fire survivors moved on to Zen. We've seen in June 2022 changes to Part B incorporated a number of sections of balconies. There are some particular very specifically worded phrases in there which have been seeking various parties' interpretation of and don't give us an interpretation of them. But in general terms, one of the major things there, obviously helping bring the height down from 18 metres to 11 metres, is the fact that non-perforate soffits are mentioned several times under the balcony section. That's something we've been advocating for years. It does make a big difference to oxygen, will be sucked in, members falling and so on, and it also makes a huge difference from the risk of things like feet cocking mud down over and any up for the rest of below. So what are the 3 big impacts? First one is cavity fire protection. And what we're seeing now is that whilst they're on the exemption list and they're covered within the exemption list in Part B as well, most thermal breaks are now leading to the Class A1. And we can certainly offer a Class A1, but also the fire protection around the stub guard, which is what that other things, which is a CNC machine component. And the second thing is obviously the deck and soft materials. The deck materials have generally changed over to a Class A2 aluminium. There is actually some Class A1 materials now. Deck for certainly the company we use, My Deck, they now offer a Class A1 fire tested product. Soffits generally a Class A2 and generally non-perforate now. Balustrade choice is probably the single biggest impact. Obviously, people are choosing to go to non-combustible, being combustible, and that's the right thing to do, and that's regardless of the height. But the lack of choice is a major factor, whereas with why people are tending to go to the vertical bar in this country. So that's quite a big switch over from the balcony industry point of view. And then we had COVID. So COVID, obviously, changed everything, but certainly come about with what you saw people use their balconies for clapping carers. We saw using it to that instrument and the local residents and so on. We saw people furnishing their balconies. We saw using it, engaging it more with growing and various other activities. So it really reconnected people with the whole purpose of why outdoor space is mandatory in London. During that period of time, a company, Skies, who basically is a resident, they have a resident community which were in apartments. There's 2 interesting pieces of feedback from one of their surveys. One was that with 2 pressing needs for people were wind protection and privacy. The second one here is the fact that the vast majority of people, 63% of people, wanted a height of balustrade which is higher than the regulatory height. So we're saying goodbye to laminate and hello to confusion. So what can we have? The Baltimore Tower, beautiful tower, got glass floors, triple laminated glass floor, and a laminated glass panel, 12 by 12, one around the outside of the door as well. And we have that. Then we go over it is not on the exemption list. The second one, using the very clever design, the solid screen clids onto glass. Again, it as I'm using a laminated glass. And funny enough, I was just working on my PowerPoint and my 3D on door thing and asked why crosses of the pictures. I explained that they're meant to be burnable in her language. She said, but glass doesn't burn. And she has a really good point there, is that it's quite difficult to explain the whole reason why these are really considered hard hit. So what about the third option there? That's a monolithic glass. Well, reality is it is a Class A, but you can't use it because CDM Section 7 designing out that risk or the open gaps. We would hate to see another crack into like what happened in Sheffield. And as somebody mentioned earlier, testing of Class A solutions, we are aware and we were very excited when we first came across this product here, which is Class A, which has a Class A certificate. Now, when we did extensive testing in our test lab at Reading, if any of you ever want to come and see that, you're welcome to come along. But there was a few things which we found really concerned us. Is the whole reason that they become popular was because of safety reasons. And here we were testing products which actually, because of the creep the gel into that has, while the TDB or EVA, what that meant is that the balcony balustrade failed and deflected far faster than what we all would. It also, when it failed, both those panels tended to go quicker together, and you then had big sharp chunks of glass which would gel together, as opposed to having a sheet which was holding lots of little pieces together. So we as a company decided that at that stage we would not offer this here as product. The other thing to be careful with, if you do choose to use it, other than it being more than 2 pound a meter, is the edge strip is not it is not UV resistant, and it also is a Class A because it fits within the 1% on the test which was done. And the test which was done on a 12 plus 10 mil glass and quite sizable panel. If you change those parameters, you might perform differently. So if you do plan to use it, and look out. So in essence, the only solution which people are starting to kind of consider or think about, and it's certainly not by any means an ideal scenario, is using preschool strips of monolithic glass. And the thought of Class A is still residing at the risk of lots of glass spawning and the ability suddenly to slip through a gap in the balcony balustrade. So we've looked at some emerging trends. I'm going to skip through this quite quick, so we know them was probably out of time yet. But what we are finding is that people were choosing Class A even before it was mandated. I think it was a good choice. Reality is it then became a fire hazard. The reason being, if people just go out to local DL license and say, I don't have the privacy, I don't have the wind resistance, then I'll get those myself, putting in kind of vertical bars to try and break the wind up a bit. But we've suddenly gone from what was theoretically a safe solution to something which is actually a fire hazard, far worse than the grass in the cell. Calibration, obviously the gateway changes and the clarity which will be needed. We're ready to support people through that process to believe that. But certainly, one of the other things we've more recently been finding is that councils are starting to realise that wind is that problem and have put wind conditions on balcony balustrading on some of the schemes. In one of them, recently was in Bristol Town Centre. It wasn't a particularly windy area. Resibuild did a survey at the end of last year. And this is interesting. This is about merging trends in the residential construction sector. Pilot obviously a big one there. But look at those other words: overheating, carbon, embodied, sustainable, zero. They're all very much related to sustainability. So obviously more metal is a good thing for the fire product. In green's really round terms, less metal is better from a sustainability point of view. Class A1 versus different types of installations, testing materials versus reusing materials with old building, concrete versus CLT. These are all kind of challenges. So what does that mean? Is it fire versus sustainability now? Well, certainly from a balcony point of view, no, it's not. And less penetrations benefits you from a cost point of view, obviously, but also sustainability and from a fire safety point of view, removing those penetrations of the facade is the best thing. And we actually have a solution now where you don't need to penetrate the facade at all, which means you don't need to worry about your captive barriers being interrupted and having to use a stub guard or some kind of fire stopping material around that. If you aren't interested, feel free to reach out to us, speak to us afterwards. Offsite manufacture, Clyde spoke quite sensibly on this. Pretty agree with the benefits of that from both fire and sustainability point of view. Digital traceability, in much the same way as Ty will talk about as well, we have a system which can track back exactly who made what, or what their training was, to actually apply. So this is quite a key thing from a golden thread point of view, but also sustainability and actually work out where sources are, where waste comes and so on. They're all part of what we're doing around that. Ethics, we can't overemphasize enough. People having chosen to not make right decisions about what they made public in terms of fire certificates. In the Grenfell hearing is an absolute tragedy. But certainly we're seeing the same direction from the industry in greenwashing now as well. So this is a massively important thing which needs to be eradicated, and this will each of us in the process sure that what we're doing is the right choice, the right approach. Science-based testing certainly is a big thing around fire and safety more generally, but also from the environmental point of view, where actually out carbon emissions and so on is essentially the same approach as based on science. And the role of innovation, this is something which has been touched on several times today as well. Innovation plays an absolutely essential role. If we're not changing anything, we're not picking up the pace or change elsewhere in the industry, ultimately will become extinct. And this is where really the innovation plays a key role in matches, reducing penetrations, for example, or creating fire software around that. So that there's lots of effort and energy going into that thing. So we think we'd like to see more site production in balconies as we go through the years. A drive to measure and demonstrate competency, and these are good things. Digital traceability is a must. Ethics are not nice to have, but a must to have. Increasing testing and science-based decisions is certainly something you'll see a lot more of, and the dependence of the nation. Also, hopefully, a future of laminate glass. Unfortunately, I'm on an MBA for certain things relating to laminate glass, but there is some light at the end of the tunnel, is about all I have to say. Certainly consider your approach regardless of building height. Look to always use soffits in your balconies. It's not a cost decision anymore. Making that choice is certainly a safety consideration, and actually improves the aesthetics. Certainly aim to minimise the balcony penetrations. We have an online readily available tool called Coach Balcony software, which is pretty available. You can actually see how many penetrations and what you can play around with the square meterage to minimise the amount of penetrations into the building. A simplistic innovation is very, very critical. And what I mean by that is if we can create stuff which can't be misinterpreted in sites, can't be pulled the wrong way up. For example, like the stuff guard, got sets of holes which are different from one side to another, so you can't actually end up with it the wrong way up. These are simple things, but ultimately, depending on the reliance of skilled workmanship is a good thing. It doesn't mean there shouldn't be skilled workmen on the site for obvious reasons. Certainly, there's a wealth of other learning on the Reservoir platform. We contribute to that a lot, and so do other brands. There's lots of topics around fire and various other things. So let me conclude that ultimately, we need to stop considering balconies the mere metal construction, which we need to get fire rating of. We need to broaden the outlet more generally, and in with the harmony of folk considering how balconies are used and how balconies are built. We should then be looking at a more safe and sustainable future, not just for the now, but also the generations come. Thank you very much.